In this video, I will be sharing more about how double indicator titrations are used. This video hopes to share more about the rationale behind the use of double indicator titrations. In the titration of a mixture of sodium carbonate and sodium hydroxide against hydrochloric acid, both sodium carbonate and sodium hydroxide are base, hence they will react with hydrochloric acid. Thus, 2 volumes of hydrochloric acid are needed. If only phenolphthalein is used, only 1 volume of hydrochloric acid will be obtained. If only methyl orange is used, only 1 volume of hydrochloric acid will be obtained. The solution will be to use phenolphthalein, then methyl orange. This will provide us with 2 volumes of hydrochloric acid used, and we can use this information to calculate the amount of sodium carbonate and sodium hydroxide present. Therefore, when 2 bases are present, double indicator titration is used. Using the respective titration curve of sodium carbonate and sodium hydroxide against hydrochloric acid to explain how double indicator titration works in a mixture of bases. Sodium carbonate is a diacetic base. It has 2 verticals seen on the curve, hence it has 2 equivalence points. Sodium hydroxide is a monoacidic base. It has 1 vertical seen on the curve, hence it has 1 equivalence point. The working pH of phenolphthalein is between 8 and 10. If only phenolphthalein is used, HCl of hydrochloric acid is needed to react with sodium carbonate, and HCl of hydrochloric acid is needed to react with sodium hydroxide. Hence, the reading on the burette will be X plus Y. The working pH of methyl orange is between 3 and 5. If only methyl orange is used, 2 HCl of hydrochloric acid is needed to react with sodium carbonate, and HCl of hydrochloric acid is needed to react with sodium hydroxide. Hence, the reading on the burette will be 2X plus Y. Hence, the solution to solve this would be first use phenolphthalein and titrate the mixture containing sodium carbonate and sodium hydroxide. The reading will be X plus Y. At this reading, all of sodium hydroxide will be reacted and sodium carbonate will react to give hydrogen carbonate ion, which is a monoacidic base. Hence, when we subsequently add methyl orange, we can continue to titrate the solution. The solution is initially yellow and will be orange at the end. The reading will be 2X plus Y. The difference between the second reading and the first reading will give HCl of hydrochloric acid. This will help us calculate the amount of hydrogen carbonate ions present. This will help us find the amount of sodium carbonate and sodium hydroxide initially present by simple arithmetic calculation. Thank you for watching this video. Please repeat if it's necessary.